Okay, and so now we can leverage the supervisor clusters control plane and the services like the TKG service, which also works with the network service and the storage service, etc., to create these Tanzu Kubernetes clusters and get them connected to all the resources that they need. So it sets up the virtual machines, sets up the clusters, and configures the clusters. And so we can see in a namespace we can have one or more Tanzu Kubernetes clusters. So you might have a team, a developer team, and they may need dev and test and prod, and they may have some workloads that need to set up and tear down Kubernetes clusters. You can allocate them in namespace, and just like in Kubernetes, our namespaces have buckets of capacity that we can associate with them as well. So I can actually give a developer access to restricted access to with their appropriate permissions to the Kubernetes API on my vCenter environment, and say they're allowed to spin up Kubernetes clusters in supervisor namespace 1, which is restricted to X CPU, X memory, other policy requirements. And so if you do have teams that need to be able to spin up Kubernetes clusters themselves, maybe they've already been used to going to a cloud provider now or trying to get a similar service on their own IT infrastructure. And so this is capable of giving that ability to dynamically spin up and tear down a Kubernetes cluster if they need to, but still also bounding that the capacity that they're able using it to ensure that our policy and controls are enforceable. Okay, and let's look at supervisor namespace 2 here, and look, we can see that we can deploy other things as well. On one hand, we can deploy Kubernetes grids, Kubernetes cluster, but we can also deploy native vSphere pods. We can deploy other virtual machines. Really, we have the option of accessing these other types of vSphere capabilities and resources within our Kubernetes, our supervisor Kubernetes space, right? And keep these isolated. And so this is really a powerful thing because, right, your applications aren't just containers, and they're not going to be. Even if it's things like services that you provide to users who are developing for containers, there's all types of services that they need that may be better served from virtual machines. And in many cases, there's applications that are transitioning. Some parts of the application are going to transition to containerization, to containerize. Other parts may stay VM. Maybe there's a hard problem in certain ones, and there's nothing wrong with that. In many cases, there's certain types of workloads where even the most aggressive native people I know say, that application type might be better suited for virtual machine. So for really the foreseeable future, the modern applications are going to use and require connectivity between these environments, between virtual machines and other types of services, and our Kubernetes clusters. And the supervisor constraint really gives us the ability to say, hey, here's an application that needs these. We can create a security boundary around maybe a particular application, or perhaps a particular developer team. They're developing some particular type of application. They need a range of different capabilities. They need virtual machines, et cetera, that their application can communicate with. And so with these constructs, we're able to define that and really put a new, more flexible multi-tenancy security strategy around them that frankly, gives us a lot more power and agility at the same time. And so looking at our other namespace here, nothing special, but just a more of the same here. This idea that this is what the modern application looks like here, right? Where we have some services running on Kubernetes, perhaps some serverless functions, and those may run natively on this Kubernetes cluster, or perhaps we can connect our namespaces through a service mesh to access central services that are delivered here through service mesh, or maybe we have some workload types that need to run on specialized and certain nodes that have a GPU, or maybe Windows nodes, as well as predefined database types that we can deploy in the namespaces. And so really this supervisor cluster and this workload control plane gives us a whole new way of delivering this robust, dynamic, multi-tenant environment here for Kubernetes and cloud native development. And so with that, I think we can really understand that this is more than just slapping Kubernetes, right? We really have a lot of native insight, and we really built this for multi-tenancy and for the very complex demands of the modern enterprise. So we can have operated, developers get self-service, operators can define the governance, and it's a model. I mean, that's been the hard problem, right? Is you can go to a cloud provider, you can do consumerization and bypass all the security controls, or you come to IT and they may or may not have the service that you want, and how you actually get it, how you get approval for it, the processes you have to go through to make sure that things are according to policy. There's a huge difference in flexibility between I can just go grab what I want in the consumerization model and IT. And I think the only real way to solve that is finding a really flexible, powerful way like this to be able to empower that dynamic flexibility that developers want, and give operators the flexibility to impose the policy and restrictions that they need to without getting in the way. You can come get what you need. You may bump into one of our guardrails, and then you can come ask. But in general, this gives us an opportunity to make sure that you're happy, we're happy, and we can get the developers happy, the operators happy, and we can move forward with the new capabilities with full agility, right, to take advantage of the new opportunities.